These are your one notes on variables and expressions. Should be a pretty easy section for you today. In this lesson, we're going to learn how to change words to symbols and then symbols back to words. Some vocab for us here. An algebraic expression are the sums and or products of numbers and variables. Now I know it says sums, which implies addition, and I know it says products, which implies multiplication, but if you add a negative number, it actually brings in subtraction. And if you multiply by a fraction or a decimal of a number, it actually brings in division. When you take half of something, it's like dividing by 2. So technically, an algebraic expression is just adding, subtracting, multiplying, and dividing numbers and variables. Variables are symbols that we use to represent numbers or values that we don't know. They're unspecified. We don't know their value, so we just assign them a variable. So it said letter. The most common variables that we use in math is x and y, dealing with the coordinate plane. When we write our variables, we make them lowercase, and we just try to make them a little scripty, a little italicized, a little fancy, just so that we can understand that they are actually representing a number. Sometimes if we don't put the little curly X, it looks like a multiplication symbol. You can't use O because it looks like 0. If you're going to use I so that it doesn't look like a 1, you want to use a lowercase I, maybe put a tail on the end of it. So they're just there to say, hey, I don't know what this number is right now, but when we find out what it is, I can replace it. A term is part of that algebraic expression, so it's part of the things that we're adding or subtracting or multiplying or dividing. It can be a number, it can be a variable, it can be product or quotient of numbers and variables, so it'd be a combination. So 3 is an example of a term, it's a number. M is an example of a term, it's a variable. 2x is a product of a number and variable. You can multiply variables, x, y. When we have a quotient, the quotient is actually, well, you can do 1/3 of x, but I want to show that that is the same thing as x divided by 3. So a lot of times in algebra, they won't write the 1, and so I want you to just understand that 1/3 of x, that's multiplication. There's really an implied 1 right there with that x, but a lot of times they drop it. That will be just something that you get used to as you move along in algebra. A power. I have 2 powers written down below. A power describes an expression in the form of x to some exponent to the nth power. It represents repeat multiplication of a base. So using these 2 terms here, this is your exponent. 4 is your exponent. 3 is your base, and that little exponent is telling us how many times to multiply 3 by itself. This entire thing is what we consider the power. And so when you look at 3 to the 4th, 3 to the 4th is just saying 3 times 3 times 3 times 3. 3 to the 4th then is equal to 81. Over here we have a variable raised to the 5th power. Again, 5 is the exponent, m is the base, and the entire thing is considered the power. And the 5 is telling us that we're just going to multiply m by itself 5 times. We really don't have an actual number for that because we don't know what m is. All right. Verbal phrases of operations. So we're just going to kind of collect a few words that we think represent these things, little key words that we can use to replace our verbal sentences. So in this lesson, we're going to change words into symbols or symbols into words. So we need to know which words are associated to which operation. So for the plus sign there, that symbol, we have plus, we have add, we have increase if it goes up in value. May say totals, that's going to be something that's actually an equals sign, but it's equals, it's telling us that we're going to be adding. So plus, add, increase, and then I want you to write sum. But when you do a sum, they got to give you the and. So a big misconception here is a lot of people think that and belongs to addition. People say, well, and, because you're totaling things up, and it means they're giving you a list. That's true, but and is in actually all four of these operations. So if you see an and, you kind of have to look back further for the word of what you're doing to them. It's a sum of 5 and 3. Sum implies that they want you to add 5 and 3 in that statement. This little dash here represents subtraction, so we could say subtract. We could say minus, plus and minus. These are just opposites. So I'm kind of using the addition one to help me with the subtraction. So I have add, subtract, plus, minus. If I have increase over in the plus, I should have decrease in the minus. And then for that whole and statement, the answer to a subtraction problem is called the difference. So the difference of some number and some other number. So again, in order to say and, you got to look at this first word. So if they say difference, they want you to subtract. If they're saying sum, they want you to add. All right, this little X, or this cross here, is multiplication. So multiply times. I think it's really any variation of multiplication there. And then the answer to a multiplication problem is product. So the product of some number and some other number. Again, there's that and showing up. It has to go with product. And then the little dash with the two dots above it implies division. So if it's to multiply, it's divide. There's not a whole lot with that you can say. You can also say ratio of. Ratio implies that you're going to divide anything with a fraction. And the answer to it is quotient. So quotient of some number and another number implies that they want you to divide those two numbers. I forgot to include less and less than. It's really important. There is a difference between less and less than. Subtract and subtracted from. Subtraction and division, the order is really important as to how you actually write that down. So be careful of the order. You got to think about what do you have and what are you subtracting. What did you have to begin with? Are you taking that away, or is that your beginning number? So because order is really important in subtraction, you got to be careful of those. And so if you look at these three little examples here, A times B would be written as, for multiplication, A times B can be written as A dot B. It can be written as A times B. We kind of get away from those, though. That's sort of elementary and middle school. So whenever we want to multiply two variables together, we simply just put them right next to each other. No spaces in between, and that implies multiplication. We could put parentheses around both of them. We could put parentheses around one of them and not the other, or the first one and not the second one. But this is the preferred choice when we get into Algebra 1. And then a couple other things I wanted to mention here. Anytime you see the little 2, for words up here, that does mean repeat multiplication, but anytime you raise something to the second power, it's squared, so that would be n squared. And anything raised to the third power is cubed. So just so you understand that terminology of words to symbols. So those exponents, those are two exponents that we have different words for. Other than that, you would say to the fourth power. All right, so let's practice this. We're going to take these words and put them into symbols, and then we'll switch it up on the next screen. So 6 more than a number. I can see the more than is plus. Now, did we put more than in here? We didn't, so I'm going to add that. I guess I should have added that when I put my less than over here. More than, less than. 6 more than a number. Now, technically, you're adding 6 to a number that we don't know. So when it says a number, let's just use the variable n. You could use any variable you want, but that's our unknown value. Technically speaking, 6 more than a number would be n plus 6. But if you add 6 to a number or you add a number to 6, it really doesn't make any difference. Technically, we could put 6 plus n. So those are both right. This one's a little bit more right than the other one, just for the fact of order. What did you have? You had a number and you added 6 to it. 2/3 of a number. Here's a keyword of. So let's go back and put that in our multiply. Of and by are keywords that they sometimes, when they give dimensions, 2 by 4, it's going to imply dimensions, multiplication, and then of implies multiplication as well. So 2/3 of a number, here's our variable, so 2/3 of our number. So you can put the 2/3 out in front of the variable, or sometimes people prefer to actually multiply the numerators and put it over 3. So either one is fine. 10 less than the product of a number and 7. Okay, so the product and 7, that is implying multiplication here. So they want us to multiply a number n and 7, and then they want us to take 10 less than that. 10 less than that tells me we're going to subtract, but the 10 has to go last, because we're going to take 10 less than the product of the number and 7. So what it does is it makes you rearrange the order of these things. In this particular case, it's so important that we put the 7n first. So the product of 7 and a number, and then 10 less than it. That's a lot different than if we put the 10 minus 7n. Just like 5 minus 3 gives us 2, but 3 minus 5 gives us -2. They are not the same. So order is really important with subtraction and division. All right, for these, we can write the verbal expressions, so we can put them in words. Several different cases here. I'm going to kind of skip around here a little bit. So for the first one, we can do 3. When it's written next to the variable like that, it means multiplication, and then we have subtraction. So I might say the product of 3 and a number. I don't want to see m. I want to see that you know that that represents an unknown value. Minus 8. Several different answers for that. That's one of them. For number 2, we got that squared, so we're going to say a number squared, and then we have a different variable. I have m and n in here. So I'm going to say a number, but then to reference that I'm not talking about m anymore, I'm talking about n, I'm going to say, for the 3, I'm going to say 3 times a different number. So I just need to make a difference between those. So I'm going to say a number squared plus the product of 3 and another number, or a different number, but just trying to signify that I'm not multiplying m by 3, I'm multiplying n by 3. And let's just do this last one, 3/5 times h. I might say 3/5 of h. So 3/5 of a number. I could say times, I could say the product of 3/5 and a number, and I'll save 4 for another time. Lots of different options there. So for your lesson summary, what I need you guys to do is write an algebraic expression of that verbal expression, and then I want you to change this verbal into an algebraic. Good luck.